Hello everyone, thank you for joining me. My name is Ronen Kofman and I'm Director of Product Development for Oracle OpenStack. Today's presentation is about the Oracle distribution of OpenStack and specifically how we make OpenStack an enterprise-grade solution. What we're going to cover today is a little bit about OpenStack, what OpenStack actually is, and then we're going to go over and talk about what is the Oracle distribution of OpenStack, what is the product. We'll follow that by discussing a little bit what are the requirements for making OpenStack an enterprise-grade solution and what is it that we're going to do about it, and we'll summarize. So a little bit about OpenStack. OpenStack is an open source project written in Python which is meant to provide a cloud management software. OpenStack is designed to be extremely scalable and allow for very large deployments. Recently, OpenStack has become a very popular project, and there are many people and companies contributing to this project. The project is comprised of several services. Those services interact with one another and they create a fabric or an environment where customers can deploy and manage their virtual machines, or as they call in OpenStack, instances. There are services to support storage, there are services to support networking and compute, there are services for identity and other features. The beautiful things about OpenStack is that all the services are extensible. Users could extend them and connect them to existing pieces of the environment they have. For example, if they have particular storage, they connect it to that special storage, or network, they connect it to their network of choice. In this slide, we can see an example of what I just described. So OpenStack is mostly about abstraction and integration. In the low part of the slide, you can see different options for compute, for example. You can see that OpenStack supports KVM, it supports Xen, Hyper-V, it can support Oracle VM or VMware or Docker or Linux containers. For network, there are some examples here of network options that the customer can use, and same for storage. So the customer, if he has existing investment in Oracle VM, for example, can connect OpenStack to control Oracle VM and then use the networking gear that he already has, and same for storage. And now what makes it all easy to use is that OpenStack provides a level of abstraction, a common interface, an API. And regardless of the underlying technology for compute, network, or storage, users could simply use the same automation system, same orchestration mechanism to control their OpenStack environment. In this slide, we see a little bit about the momentum of OpenStack. We see two graphs here, and one of the graphs describes how many different individuals have contributed code to OpenStack. The other graph describes how many companies are involved in the OpenStack project. So since its inception in 2010, 4 years now, OpenStack has grew in a very rapid way, as we can see. Today there are, in the last release, and we are close, slightly before the June release today, there are 1,450 different individual contributors who contributed code to the OpenStack project. And we see this trend continues in a very rapid pace. We see the same trend for the companies. There are a lot of companies. In recent years, some of those companies merged or changed, and that's why we see a slight decrease in the number of companies, but still we're talking about more than 200 companies who are involved, invested, and committed to the OpenStack project. So let's talk a little bit about the Oracle Linux distribution of OpenStack, or as we call it, Oracle OpenStack for Oracle Linux. So Oracle OpenStack for Oracle Linux is now available. and it consists of several pieces. So we support the compute service Nova, and under the compute service we support two types of hypervisors, Oracle Linux with KVM and Oracle VM with Xen. We support the Neutron networking service, which allows customers to connect to different types of plugins and use different technologies for their networking. We also support Cinder. Cinder is the block storage service, and it allows users to use almost any kind of storage they wish to serve up to their virtual machines. We support the Swift object storage. We support the Glance. Glance is part of the system. It's the image registry. It allows users to upload images and manage them. We support Horizon Dashboard, which is one way to communicate with OpenStack. And we support the Keystone authentication service, which is a way to authenticate users, a way to connect to your corporate LDAP or your corporate authentication management system, and a way for services to authenticate each other when they're making calls between one another. So one very important piece of the OpenStack solution from Oracle is the choice. So we make sure that while Oracle can provide the entire solution top to bottom, and we'll show that shortly, Oracle also supports integration with other solutions. So if a customer, for example, wants to use another distribution but still want to use Oracle Linux, we will support him, and we'll make sure that we could work together with that distribution. And the two announcements that Oracle has made were with Mirantis, that Mirantis distribution will support Oracle Linux and Oracle VM, and with Canonical, saying that Oracle Linux will be supported on OpenStack from Canonical. So having said that, we also want to provide choice of third-party plugins. So we already made some announcement. Oracle has already made some announcement and continues to making them, where we go together with a third-party vendor, whether it's a storage vendor or a network vendor, to make sure that our distribution works properly with this third party's gear. So we've done that, we'll continue to do that, and the openness part is very, very important to us, very key. I think it's an important differentiator for Oracle. Some of the competitors have decided to provide solutions which are more locked in, and Oracle decided to go take a different route there. In this picture we see how we can deploy actually an entire Oracle OpenStack deployment using Oracle pieces. So let's start from the middle. You see there several servers, and every OpenStack deployment there is a compute servers, multiple of them usually, and there is a control node, sometimes more than one. So the compute servers have either Oracle VM or Oracle Linux installed on them, and they can provide compute service for Xen, using Xen or using KVM, either for Oracle Linux or Oracle VM. The control node is installed on Oracle Linux, as we see, and this is the node where all the services which are non-compute, as we said before, Keystone, Glance, the Neutron server, are installed. So this is where the servers are installed, Oracle Linux, Oracle VM. On top of them, we install the Oracle OpenStack for Oracle Linux product, which again consists of compute and control nodes. This is the red square there that represents OpenStack. On top of the compute nodes, we launch instances or guests. Inside those guests, we could also install Oracle Linux. So you get Oracle Linux at the bottom on the compute node. You get Oracle Linux in the guest, and it's all supported by Oracle. But that's not enough because OpenStack has some more pieces. One very important piece in the OpenStack deployment is the database. So the common database used in OpenStack is MySQL, and Oracle owns MySQL and continues to develop it. And so users could choose to purchase support from Oracle for MySQL database, which is used for OpenStack. Now users can go ahead and purchase more advanced options of MySQL with MySQL Enterprise and get the Enterprise backup and other features that the MySQL Enterprise provides. So users, again, have a range of options there. In order to keep the entire deployment up and available, we have to provide a high availability layer. So we chose to use the Oracle Clusterware. Oracle Clusterware is the software that runs under Oracle RAC as well. And this is a high availability management software which provides high availability, in this case for the OpenStack services and the database. And what users can do if they have Oracle Premier support, they could actually use this software at no additional cost. The other thing that we provide from Oracle is a driver for ZFS storage appliance. So on the lower right hand side you can see the storage option here, which is a ZFS storage appliance. And the ZFS storage appliance team has created a Cinder plugin. Cinder is the block storage service that we've shown earlier. And users could actually mount iSCSI LUNs or NFS up to their virtual machines or to their servers. So again, you could get the storage option directly from Oracle. Oracle also announced the availability of the Oracle Virtual Networking plugin for Neutron. So Oracle is capable now of supporting all the three pillars, which are compute with Oracle VM, Oracle Linux, storage with ZFS storage appliance, and OVN, the Oracle Virtual Networking. That would be the networking piece, and all supported by Oracle. And all of this is available at no additional cost on top of Oracle Linux Premier support. So in other words, if you have Oracle Linux Premier support, you are already supported for OpenStack. And this is a very useful option for our customers. So as we mentioned earlier, there are several ways to deploy OpenStack. There are several options for compute, and there are several options of integration, either with other distributions or with third parties. The most common ways to deploy OpenStack are either all-in-one. All-in-one is an option which is very useful when testing OpenStack. That means that all the services that I described earlier are actually installed in a single node, including compute and control. This could provide a very useful starting point when you want to test your orchestration, when you want to test the integration with those third-party plugins that I described earlier. So that's one option which is available and supported, not for production, but for test and dev. The other option is multi-node deployment. So OpenStack is very flexible. You can deploy OpenStack services in various ways. You could actually take each and every service and deploy it on a different node. Actually, you can deploy service or more than one node for high availability, which is how we do high availability for OpenStack. But the common way to deploy OpenStack is to keep all the API services together, as you see in this picture, and then have the message queue and have the database on separate nodes, just because they are being heavily used, and we want to make sure that there are no bottlenecks for those services. The other common thing to do is to take the OpenStack Neutron and put it on a different service, a different server, And the reason for that is to assure that we don't have any kind of bottlenecks for the network traffic. All the network traffic is using the network node, and so it's going to be a fairly busy service. So that's why we put it in a separate node. So just in summary, we have a way to deploy OpenStack in any way that you want, either service on every node or couple several of them on the same node, or take all the control and put it in one node and have many compute nodes. Everything is optional according to the customer needs and the deployment and the requirement that the customer has. So as I said earlier, the ZFS storage appliance team has created a plugin for Cinder, for OpenStack Cinder. So as of version 8.2 of the ZFS storage appliance, users can download and install the Cinder plugin on their OpenStack Cinder service and connect to ZFS storage appliance. This will allow users to create LUNs, delete LUNs, extend them, replicate, snap them directly from OpenStack. They don't need to go to the ZFS storage appliance, and that's a very useful option to have. The other cool thing about the ZFS storage appliance is that it has a VirtualBox simulator. So if you don't yet have a ZFS storage appliance, but you do want to try the plugin just to test your control plane or to test your orchestration, you could go ahead and install the VirtualBox simulator, and then you could actually develop a complete orchestration and the control plane for your OpenStack environment. Once you're ready, you swap it with the real thing, and you put in a ZFS storage appliance. It will work exactly the same. So that's a very useful option. Also, as mentioned, the Oracle Virtual Network now has a Neutron plugin for the network service, and this makes it a very powerful option for OpenStack users. So the OVN has very good and secured multi-tenancy features. It could provide very high performance network, much more than 10 gigs, the standard 10 gigs. We could support quality of service per network, and that becomes extremely important in an environment such as OpenStack, where you have all kinds of tenants and all kinds of workloads that needs to provide a certain level of services. And this is probably almost the only option to do that in OpenStack today, to get such high performance with security and quality of service. So Oracle Virtual Network is a very good option for OpenStack networking. So in the next slides, I'm going to talk a little bit about what does it mean to make OpenStack enterprise grade. As we've seen before, OpenStack is a very popular project. It makes a lot of progress very quickly. But there are certain things that the enterprises that need to have, and OpenStack is on its way to get to implement those things. And part of our role, part of what we try to do at Oracle, is look at those things and try to focus our energies and our resources on solving those challenges. So what does it mean to have enterprise-grade product? The first and most important thing is what we call operational efficiency. Or in other words, it needs to work, and it needs to work in a way that is easy to maintain and support. So let's see. So first thing is it's easy to operate. It's intuitive. Every administrator, and there are going to be a lot of administrators dealing with it, is capable of running and working with the product. The second feature that the operational efficiency means is being able to monitor, to see things are going well, to report back that things are working, to be able to report back about who's using what are the resources that are needed, to be able to predict what kind of resources would be needed in the weeks and months to follow. And then comes the other issue. When things need some maintenance or support or don't quite work, it needs to be fairly straightforward or easy enough to support and maintain them. Meaning, if something breaks, it's easy to replace it. If something fails, it's easy to restart it. And it's not becoming a very complicated operation to fix or support or maintain an environment, an OpenStack environment. And the last thing that sometimes happens is ability to recover, meaning if something breaks in a very bad way, then there needs to be a way to recover from that situation, either disaster recovery or even high availability cases where you need to swap some of the pieces of the environment. So operational efficiency means that the team on the ground is capable of managing this entire process, and there is a little dependency on external resources or the vendor preferably. And that is something that OpenStack needs to improve on a little bit. It's still fairly complex today, and that is one area where we're focusing on. So the other thing that makes OpenStack Enterprise great, so there is a famous discussion in the OpenStack community about pets versus cattle. Pets are those applications that are needs to get a lot of attention. They get names. They are nurtured back to health when they're sick, if you will. And those are the type of application that we call pets. And there are the other type which are called cattle. They have just a number, usually not a name. And when they fail, you bring up another one. And so when we say enterprise grade, we mean that the product needs to be able to deal with pets and cattle. And we know OpenStack does the cattle part well today. And we want to make sure that it always takes care of the pets as well. The other aspect is high availability. We talked about it. We provide an option if something breaks, something else comes up. And that's another big requirement. Another requirement is security. And secure means whatever the customer means is secure. And what I mean by that is that security is never something that could be decided by anybody other than the customer. Every customer may have different compliance and security requirements, and we want to make sure that the customer could implement his security and compliance requirement within the OpenStack environment. The fourth is integration. So we talked a little bit about integrating third-party plugins and integrating with other perhaps orchestration tools in the data center and other capabilities. OpenStack is doing quite a good job there, but still requires some more work. Another requirements is scalability. So scalability and performance, we know that we want to make OpenStack a very scalable option. We want to make sure that customer can deploy hundreds or thousands of servers of OpenStack, and we need to provide the features to do it and the best practices on how to do that. Another requirement is, of course, quality and reliability. So basically, quality is defined as the thing works and doesn't break or working according to spec. And reliability is working for a long time and doesn't break in the long run. And so this is also something that data centers want to get to. They want to make sure that the solution that they choose just continues to run. Another thing which is very important to enterprise customers is seeing when a new version will come along, knowing what is the roadmap, and improving on predictability. OpenStack has a pretty rapid deployment, release process, and it releases every 6 months. Most of enterprise customers take more than 6 months just to test their intended deployment. And so we'll need to provide, as a product, a roadmap and predictable way for customers to know when is the new version, what's in the new version, and that they have a safe and reliable path to upgrade. And these, I think, is the things we're looking at when we look at making product enterprise grade. In some of them, OpenStack does fairly well. In some of them, OpenStack needs to improve a little bit, and that's where we tend to put our efforts. So some of the challenges that OpenStack faces, there are several challenges and several areas that we've identified. And we've identified them by trying to deploy some demanding application and figuring out what are the things that makes it harder. So what we came up with is a list of features that we think we need to pay attention to or improve or implement. And the feature, and some of them are written here in the slides. And on the storage space, we realized that, as we said before, pets is a big deal for data centers. There are a lot of applications that are not just going away, and you can replace them over by starting another instance. And so persistent storage is a very important piece of OpenStack that needs to be improved a little bit. And persistent storage, meaning storage that remains after the instance terminates, is available in OpenStack, but still needs to improve a little bit to meet the requirements of those pets. Storage network security. It means that the networking for storage these days are not controlled by the security facilities that OpenStack has, and that's something that also needs some attention. Portability, QoS, basically assuring a certain QoS and also providing NFS for directly to the instances. Today you can do that, but the performance that will be shown is a little less than ideal, and that is something that is being worked on. On the compute side is in a fairly good shape. There are very few features. One of them that we've discovered is the placement. There is no convenient way to define placement policies today in OpenStack, meaning where do I want this instance to land? Because if you've got a highly interconnected application, you want to make sure that the networking is such that the instances are in close proximity to each other, and they're not doesn't need to be multiple hops between one instance to the other. The other thing is affinity, assuring that two nodes don't land on the same server or two nodes do land on the same server. These are important things when you have multi-tier applications and you want to make sure that they're highly available. So you don't want to put all the eggs in one basket. On the one hand, on the other hand, you want to make sure that the eggs are not spread around too far. So those are the two things that Affinity takes care of, and Affinity is yet not a feature in OpenStack. On the networking space, we've seen that the data path is not redundant today and has some multiple single points of failures we want to improve. Quality of service is also important here. On the control plane, there is some complexity, and scalability has reported to have been an issue, and these are the things that we identified that needs to improve. On the security side, we've seen that role-based access control, while available, probably could be improved a little bit, and user management is something that we identified as something which is not complete for an enterprise environment, and we would also like to look at that. In terms of support and maintenance, as we said, live migration is a feature which is available in OpenStack. Again, needs some improvements. Monitoring, there are various monitoring options for OpenStack, and we have to see that we choose or integrate the right one or the one that will be a good fit. And there is upgrade. So there needs to be a way, an easy and simple way to upgrade from one version to the other. Today, there is a way to do that, but we want to make that, again, a seamless, more simple experience for customers. So those are the some of the challenges that we face, that OpenStack face, and we identified, and we're focusing our efforts on. But in general, that's our theme. We want to make sure that we identify those barriers for adoption for OpenStack in the enterprise, and we take care of them. We either work with others or work in our team to improve and fix them. There are some other barriers which are not technical per se, or some of them are technical, and more project management type things that we believe are making it more challenging to adopt OpenStack. And complexity. Complexity is has many facets to it. OpenStack is complex today, more than it should be, more than we want it to be. And this impedes user experience, it impacts user experience, and the installation process sometimes become quite involved. We know that it makes evaluations more difficult. It requires highly skilled IT team, and more than we would have liked to require from a customer. The other thing is maturity in general. The APIs tend to change rapidly, the tools, the CLI, and that needs to kind of get into a stability stage, and that's again, if a customer or even a third-party vendor that develops a plugin needs to update his orchestration tool or his plugin every 6 months, that's a really big challenge. Quality, so there's still a lot of bugs, vulnerabilities, which is expected in this rapid development process, but we want to see that improving as well, and we see good sign of that. And as I said before, predictability and roadmap are also a key thing for planning, for in general feeling confident about the product. So that's something that OpenStack is doing, but we would probably want to see a longer-term roadmap and a longer-term option for OpenStack products, and we will do that for our product, but we think that this is something that maybe the community needs to look into as well. So just to summarize, the Oracle OpenStack for Oracle Linux is now available, and as we said, it's available at no additional cost. So if you've got Oracle Linux Premier support, you get the Oracle OpenStack support bundled in it. So Oracle is investing in OpenStack, as we've seen, in several areas. We have distribution, we have one for Linux, one for Solaris. We have a ZFS storage appliance plugin, we have an Oracle Virtual Network plugin, and we hope to see more products also joining the OpenStack movement. Oracle is providing an end-to-end solution. So this is unique. So almost no other companies can claim that you can get all the pieces, all of them, fully supported, end-to-end, by Oracle. And having said that, we always complement that by saying that choice is key. Choice is key in OpenStack, and we want to make sure that our partners and our customers partners offer their plugins, and customers choose the solution which is comfortable to them, and that's the open part of OpenStack. And as I said, we're focusing on making OpenStack enterprise grade. We believe that by making Oracle application run on OpenStack, we could help the community bridge those gaps and the feature gap and make OpenStack a better product, not only for Oracle, but for the entire community and the entire potential user base that is looking into OpenStack. So our job number one is work with the community and assure that OpenStack is becoming a first-class enterprise solution for the enterprise.